Today we'll prove the Pythagorean theorem, one of the most fundamental theorems in mathematics. The theorem states that in a right triangle, the square of the hypotenuse equals the sum of squares of the other two sides. Let's start with a right triangle ABC, where C is the right angle. We'll label the sides. A and B are the legs, and C is the hypotenuse. To prove this theorem, we'll construct squares on each side of the triangle. First, let's create a square on side, then on side B, and finally on the hypotenuse C. Now let's look at a different way to prove this. We'll create a larger square with side length a plus b. Inside the square, we'll arrange 4 copies of our original right triangle. In the center, we get a square. This square's area is c squared, the square of the hypotenuse. The area of the large square can be calculated in 2 ways. First, it's simply a plus b squared. Second, it's the area of the center square c squared, plus the areas of the 4 triangles. Let's expand the left side. A plus b squared equals a squared plus 2 of plus b squared. On the right side, c squared plus 4 times 1/2 simplifies to c squared plus 2 ob. When we subtract 2 ob from both sides, we get the Pythagorean theorem. A squared plus b squared equals c squared. And thus we have proven the Pythagorean theorem using a geometric approach. This proof shows us not just that the theorem is true, but why it's true through the relationship between areas.